Okay, so now we're going to move on to section 10.3 where we're comparing two independent population proportions. So this is a hypothesis test that can help determine if there's a difference between proportions from a population. So let's look at an example. Suppose there's two types of medication for hives and they're being tested to determine if there's a difference in the proportions of adult patient reactions. So to do this kind of test, it's requiring that we have two samples and they're independent. The number of successes, whatever we're counting as the success, has to be at least 5, and the number of failures has to be at least 5. It kind of gives us an idea of how big our sample sizes need to be. Okay, and this next statement is also a guideline that we want the population to be, at least 10 or 20 times the size of the sample. So if we've got a really small population, that's not going to be possible, but we want to just make sure that the sample that we're taking is relatively small compared to the population. So that keeps the population from being oversampled and causing us to get incorrect results. All right, so we've got some notation. We have P1 and P2 are the population proportions to be tested. X1 and X2 are the successes from the two samples. N1 and N2 are the sample sizes. And then P'1 and P'2 are the sample proportions that we get by taking the X over the N. The difference of the two sample proportion follows an approximately normal distribution. Okay, so P'1 minus P'2 is approximately normal. So again, we're going to have the same steps that we do for other hypothesis testings. We're going to have a little bit different look in the hypotheses. So here we're looking at a null that the proportions are equal, or if we look at the difference, that the difference is 0. And just like when we were looking at two means, we have 3 possibilities for the alternate hypothesis, where P1 is greater than P2, so we would have the difference is positive. If P1 is less than P2, we have the difference as negative, or we could just say that it's not equal to 0. Okay, we've said that this difference is normal, and so we need to have a mean and a standard deviation. Remember that we always get the mean from the null, or from the hypotheses. Okay, so the mean is 0, right? We're saying that this difference is 0, so we're saying that the mean for the distribution of P'1 minus P'2 is 0. All right, and then we have this calculation for the standard deviation. It's the square root of this thing PC times 1 minus PC and then plus 1 over N1 plus 1 over N2. Okay, so PC that shows up is just this right here. Okay, and then our test statistic is given there. So where we have these P hats, that is the same thing as P prime. Different textbooks use different notation, so this has a little bit left over from a different textbook. Okay, and then we're going to use p-value and decision just like we do in others. So let's use this in an example. So we have our 2 types of medication for hives. Go ahead and read this and then we'll pick up and do it together. It can be helpful to create a table to kind of keep track of the different pieces. So let's say we've got a column for the medicine. Okay, so we have 1 medicine and then we have medicine number 2. And picking out from the write-up, the sample size for the first one is 200 and the second one is 200 as well. And we're given X number of successes for each of them. It's 20 for the first one and 12. In this case, the success is having a reaction. And then we can calculate P prime for each of those. All right, so for the first one, we take 20 over 200, and that gives us 0.10. And for the second one, we take 12 over 200, and that gives us p prime of 0.06. So we can use that information to come up with our null and alternate hypotheses. Well, the null is always going to be p1 minus p2 equals 0. Okay, we don't even have to think about it. That's what it's always going to be. And then the alternate, here we have to figure out basically what symbol we're going to put in there. So it's just saying that it's asking whether they are, if there is a difference. So it's not specifying one is less than or more than the other, so it's just going to be not equal to. Now we calculate the test statistic. So first thing we want to do is calculate this value p sub c, where from the notes we take 20 plus 12, right? We're adding together the successes from each of those samples, and then putting that over the sum of the sample sizes. So we get 32 over 400, which is 0.08. Okay, so now the test statistic, z, is equal to the difference in the p primes, so 0.1 minus 0.06, divided by that standard deviation calculation. So that's square root of pc, so that's 0.08, times 1 minus that, which is 0.92, times, we got to add together 1 over the first sample size of 200 plus 1 over the second sample size, which is also 200. Okay, so if we calculate that, we end up with a z value of 1.47. Now, we find the p-value using our calculator. We've got a two-tailed test because we have that not equals. So we got to remember that when we plug that into the standard normal calculator, and we end up with a p-value of 0.1416. Okay, so now we can come to our conclusion. And it says to test at a significance level of 1%. So we have our p-value of 0.1416. Well, that is greater than 0.01. It's greater than the other two that we might use as well. So we are going to not reject the null hypothesis. So we're not going to reject that the two medications have the same proportion of reaction.